If you've ever worn braces, had a wisdom tooth removed, or been told your teeth are crowded, you are part of a nearly universal modern experience. But when researchers examine the skulls of people who lived before farming, before cooking made food soft, they find wide dental arches, straight teeth, and room for every molar. No braces, no extractions, no crowding. So why is your jaw too small for your own teeth? The obvious assumption is genetics, that something in your DNA simply programs a smaller jaw. But this explanation falls apart quickly. When scientists compare populations that shifted from tough, unprocessed diets to soft, cooked ones, they see the same dental crowding appear within a single generation. That is far too fast for genetic change. Something else is shaping the jaw. Something mechanical. The jaw, it turns out, is not a fixed structure whose final size is determined at birth. It is a living scaffold that grows in response to force. Every time a child chews, really chews, tearing and grinding through tough, fibrous material, the muscles of the face pull on the bone beneath. That mechanical stress signals the bone to widen and lengthen, gradually expanding the dental arch to make room for every adult tooth. But what happens when that stress disappears? In 1951, researchers ran a direct test. They fed one group of animals a hard diet requiring intense chewing, and another group the same nutrients but ground into a soft paste. Same genetics, same nutrition, different mechanical input. The animals on the soft diet developed shorter jaws and noticeably crowded teeth. Later experiments on primates confirmed the pattern. And when anthropologists surveyed mandible shapes across populations worldwide, they found something striking. Groups that adopted agriculture and processed food consistently had shorter, narrower jaws than groups still consuming tougher, unprocessed diets. The shift was not subtle. So the picture comes into focus. Your jaw didn't undergrow because of a flaw in your DNA. It grew exactly as it was instructed to, by the forces applied to it. And those forces largely vanished. Cooked, mashed, milled, and refined, the modern diet stripped away the very mechanical resistance that jaw bones need during childhood to reach their full size. Your teeth still arrive on their normal schedule, but the arch beneath them never expanded enough to welcome them. This reframes what orthodontics actually does. Braces and extractions are not correcting a biological defect. They are managing the downstream consequences of a developmental shortfall, a shortfall caused not by biology going wrong, but by an environment that changed too quickly for the body to adapt. The upstream event happened years earlier, in childhood, in the texture of every meal. The wire on your teeth is responding to a problem that began on your plate. There is something quietly remarkable about this. The shape of your face was, in part, sculpted by what you chewed as a child. Not by destiny, not by a genetic blueprint read in isolation, but by a physical conversation between muscle and bone, repeated thousands of times, during the years when your body was still deciding how large to grow. The next time you see an ancient skull in a museum with its broad arch and flawless teeth, you are not looking at better genes. You are looking at the imprint of a harder meal.